Greetings, YouTube. This is Beautiful Mind. So we have a few more that came into us. So let's take a look at some of these questions. So this one says, a map indicates that 2 centimeters equals 6 kilometers. In this case, how far is 6 centimeters equal to? Okay, so what this is a related rate. So a map indicates that 2 centimeters, so let's see, 2 centimeters equals 6 kilometers, right? So we're doing a comparison between centimeters and kilometers. In this case, how far is 6 centimeters? So we're given 6 centimeters. We want to compare that to X number of kilometers. Okay? See how we set that up? We did centimeters per kilometer compared to another set of centimeters per kilometer. Now there's only one thing we don't know. How far is 6 centimeters? So then basically we're doing 2 over 6 equals 6 over what? Okay? So when you have one fraction equal to another, we cross multiply and solve. So then that means that 2x equals 36. And then we divide by 2. And x is going to be, 18 kilometers. Okay? So let's think about that. Now, is this a reasonable answer? Is it 18 kilometers? We're saying that this is the result. Now, if this is the result, let's see. So 2 centimeters is 1 kilometer. That means 1 centimeter is 3 kilometers. So then times 6 times 3 is 18. Yeah, that's reasonable. Okay. So let's move on to the next one. Oh, I forgot to start my timer. So 11 over 4 times 7 over 2. Okay, it's not too bad. So if we say 11 over 4 times 7 over 2, right? So to multiply fractions, we multiply straight across. So we say top with the top and bottom with the bottom, all right? Before I get those big numbers, I usually try to cancel or simplify, but nothing cancels with anything on top or bottom. So then we just multiply the numbers. 7 times 11 is 77. 4 times 2 is 8. Nothing simplifies. Because 7 is prime, 11 is prime, and neither one of those are simplified by 2. So we get 77 over 8, which would be this one. Okay. This one says, how many inches are in 3 meters? Remember that 1 inch is 2.54 centimeters. This is great. I love these. These are conversions. Man, I have memories when I was a kid. Me and my family, we'd be like in a van, traveling across the country. We would drive from like the south to the north, 10-hour drive. And I just remember my dad, he would do things like, well, if we're traveling, this is what my dad sounds like to me when I was that age. If we're traveling, I can't even say this with a straight face. But no, he would actually break out and do like rate calculations while we're driving down the road. Like he'll if we're traveling, 60 miles an hour for 3 hours, how far do we go? He'll ask those kind of questions, or he'll do things like, what's your distance behind the car in front of you? It's like, well, how am I supposed to know that? He was like, okay, look, as that car is going, see when it passes that tree, count the seconds. So then, you're watching the car in front of you, it passes the tree, and then you start counting. You go like 1, 2. So it took us 3 seconds to pass the same tree. So then he's like, okay, if we're traveling 60 miles an hour, how far are we behind the car in front of us? He'll do stuff like that on the fly. He'll do all this stuff in his head, and I still to this day don't know how he does it in his head. And then, but when I would break out paper and pencil, it would be true. And so, it was interesting because I know I'm kind of rambling, but I used to do, for following a car, I used to do, maybe 2 or 3 car lanes. He was like, no, it's not that anymore. You got to do it based on counting things on the side of the road and how fast you're going. So it's like, you want it to be like 3 seconds or so between you and the car in front of you, or whatever it is based on your speed. So it's just interesting stuff. There's that, and another one that I've seen is one of my professors. He did a demo. You might want to do a search, and maybe one day I'll do a demo on it at some point. But it's this thing called Human Calculator, and I have some tricks, but you actually have to see my hands for the one I'm thinking of. But my professor, you could do things like 247 times 352, and he'll spit out the answer faster than you can type it in the calculator. And I'm still astonished by this. I haven't looked into it yet, but there are some videos on YouTube. If you type in human calculator, there are all these tricks for doing calculations like that in your head. And it's some really interesting things out there when you really look at it. But it's like I never even thought to do it until I saw people do this stuff. So anyway, that's neither here nor there. So something like this. So it's just, this story, this question brings back fond memories for me of just some astonishing, amazing people that's been in my life that's helped me to get here. So I really appreciate them. It says, how many inches are in 3 meters? Okay, remember that one. So this is a conversion. Okay, so we want to convert 3 meters to inches. Okay, so this is how we do conversions. Let's do this color. So if we have 3 meters, usually we put it over 1 and we say times. Now we want to convert from meters to inches. Now, if we have meters on top, we need meters on bottom. Now, what's the relation between meters and inches? Well, we can go from meters to centimeters and then centimeters to inches. So 1 meter, it should be 100 centimeters, right? Notice meters on top, we put meters on bottom. Then we say times. So then we have that 2.54 centimeters is to 1 inch. Okay? So now, at the end of all of this, units of meters are going to cancel, centimeters are going to cancel. What's left are inches. Okay? So then basically, we say 3 times 100. So we're going to say 3 times 100 divided by 2.54. And whatever answer we get is going to be in inches. Okay, let me break out my calculator. No, that's not it. It's here. And no, not why isn't. Let's close the tabs. Yes, this. And let me let it load. Refresh. All right. So let's do this. So we're going to say 3 times 100 divided by 2.54. Okay? And we get approximately, I'm going to round, so that's why I put the squiggly, saying it's not exact, it's an approximation, 118. I'm going to do 2 since we had 2 decimal places, so 118.11 inches. Okay? There we go. Let's see if that's one of our answer choices. Is that a reasonable answer? Let me see. 3 meters. Meters approximately a yard. Yeah, I think that's a reasonable answer. So I got 118 inches. Okay, we'll go with that. That's my time. Okay. Let's try to squeeze in one more. I'm not sure what's going on here. 6.56 equals what? I don't know what they're asking there, so I'm going to have to skip that one. Okay, possible values of x. Let's go ahead and do this one real quick. I think we did one like this in another video, but let me show you how I solve absolute value equations, okay? And then we'll wrap it up. So then we have 2 times the absolute value of x plus 3. That's not a 3. Equals 18. So now when I do absolute value equations, first thing is you got to get the absolute value by itself. So in this case, or in other words, you got to isolate the absolute value. Okay? So I'm going to divide the left and the right by 2. 2 divided by 2 is 1, so they cancel. We have absolute value of x plus 3. 18 divided by 2 is 9. Now, what we do, we say the inside equals the right, or the inside equals negative the right. So we say x plus 3 equals 9, or x plus 3 equals negative 9, okay? Just as a contrast, I'll show the common error that people do. The common error that people do at this point, they'll do x minus 3 equals 9, okay? I'm going to show you how the green doesn't work. All right, so if we solve on the left, subtract 3 on both sides here. So then we get x equals 6, or if we subtract 3 on both sides here, x equals negative 12. Okay, so we're saying that the solution set is negative 12, 6. Okay, and then we should check, let's check that in the original. All right, I gotta wrap up. So 2 times the absolute value, we're gonna have negative 12 plus 3. Does that equal 18? Let's see. Negative 12 plus 3 is negative 9. 2 times the absolute value of negative 9. That's going to be 2 times 9, which is indeed 18. So that checks out. Let's do the next one. 2 times the absolute value of 6 plus 3. That's going to be 2 times the absolute value of 9. That's 2 times 9, which is indeed 18. That checks out. Okay. Let's look at the common error. So if I solve for x, I get, no, let's back up. Plus 3. And x equals 12, right? Now, if that was true, and we plug it into the original, it should be true. Let's see. 2 times the absolute value of 12 plus 3 equals 18. That's question mark. 2 times the absolute value of 15, is that equal to 18? Question mark. All right. And that's going to be 30 is not equal to, let's back up. 30, is that equal to 18? No. Okay, that's why it's a common error. Okay. So with this one, I would say that the solution, negative 12 and 6, this